Hi, good morning. Today's lesson is on solubility and the rate of dissolving. By solubility, we mean the amount of a substance that will dissolve in a given amount of solvent to form a solution. And then the rate of dissolving is how fast or slow a solid dissolves in a solvent to give you a solution. Now, if you click on this lesson activity, solubility and rate of dissolving, that will take you to today's lesson activities on solubility and rate of dissolving. And a lesson objective is that you will be able to explain the various factors affecting solubility and the use of the solubility graph. That is, you will be able to explain some of the factors that can affect how fast a solid will dissolve in a solvent. And also, the essential question is you able to answer the question, what are the various factors affecting solubility? Now, if you click on next, that'll give you the first slide on today's lesson. Defining solubility. You define what a saturated solution is and what's an unsaturated solution and also supersaturated solution. So these are the three ways that the solubility of a solution can be described. So you need to know the difference between all those three. All right, so if you look at the bottom here, you have a graph. In an unsaturated solution, it means that you can still dissolve more solid in solution. You can see how clear it is, so you can add some more solid. Whereas in saturated solution, there will be some undissolved solid left in solution. That's how you know that it's a saturated solution, when no more solid can dissolve in a solution. Whereas supersaturated solution occurs when a saturated solution is heated up such that the excess or extra solid that were undissolved in solution are forced to dissolve based on the increased heat. This is a very unstable solution because at that point you're forcing those excess solid to remain in solution. Any disturbance will cause them to come out of solution, which is referred to as crystallization. That's when you begin to form some precipitate. All right, so you answer those questions based on your understanding of these three terms that describe solubility. So the next screen has to do with your solubility curve or graph. So you should know how to read it, in the sense that if you draw a horizontal line and a vertical line and they meet on the line of the particular salt, that will give you a saturated solution. Whereas if the intersection is below the line, that will give you an unsaturated solution. Whereas above the line is going to be a supersaturated solution. Now, let's say, for example, you have 10 grams. Let's say here this is 10 grams. And then you dissolve in, let's say, 50 degrees Celsius. You draw a horizontal line from 10 grams until you get to 50 degrees Celsius. And where they intersect will give you an understanding of whether it's an unsaturated or saturated solution. But in this hypothetical example, 10 grams at 50 degrees, 10 grams is right here, and I draw a line and 50 degrees Celsius is here. You could see that the point will be below the graph. In that case, it's going to be an unsaturated solution. But if you had 100 grams of water, of a solid, maybe somewhere here, in 100 degrees Celsius, and let's say this is 100 degrees Celsius, and you draw a line, vertical and horizontal, to intersect both the 100 grams and the 100 degrees Celsius, they meet right here on the line. That will give you a saturated solution. Whereas if they meet above, that will be a supersaturated solution. All right, so you watch this short video that will also give you more information how to read a solubility curve. A solubility graph could include more than one sort, just like you have in this image. You have different sorts. Some are affected positively by temperature, whereas some are affected negatively by temperature, especially gases. Gases dissolve less in solution at high temperature, whereas solid and liquid will dissolve more at high temperature. Then the next one is the activity on solubility curves. So you click on each of these hotspots to give you some additional explanation. Okay, and then you try to answer these 4 questions here. And then here you still have an assessment, okay, of solubility curve. And if I click on the last one, page 5 or screen 5, you still have another activity on solubility curve. Make sure you go through each of those hotspot in order to complete the activity right here. And then finally, you'll have the definitions again, and also the various factors that affect solubility. We have heating solution, which is temperature. Increased temperature will increase solubility for solid, but will decrease the solubility for gas. Agitation, which is to stir or to shake, it will cause solubility of a solid to go up, okay? And then increased surface area of solid, that means crushing. If you grind the solid, it's going to increase the solubility of that substance, or the dissolution of the substance in solution. And then increased surface pressure of solution. Here it has no effect on solid, but it has effect on gas. All right, so, and also watch this video on like dissolves like, in the sense that if it's polar, polar will dissolve polar, non-polar will dissolve non-polar. Polar cannot dissolve non-polar. Therefore, when you put non-polar in polar, there's not going to be any effect on solubility of the substance. Whereas if you put it in polar, that will affect positively the solubility of the substance. All right, so watch that, answer these questions at the bottom, and don't forget to submit a report, and that will be the end of the lesson. It's very short, less than 15 minutes. We'll be done with this. Okay, and then I'm going to quickly also explain how to use how to do the second assignment on Gizmos. If you have any questions, send me an inbox and send me an email. I will respond. All right, take care.